Hello everyone. Thank you for joining me today for the latest Global Mapper webcast. As you can see on the screen, today's topic is an introduction to the LiDAR module. Now, this is actually the second in our LiDAR processing series that we introduced last time out. Over the course of the next few weeks, we're going to be releasing a series of fairly short videos that go through some of the key LiDAR processing components within Global Mapper. Last time, by way of an introduction, we talked about the process of importing LiDAR, a very simple procedure. Today we're going to introduce the LiDAR module, which is an add-on component to Global Mapper that provides some more advanced functionality. Now again, this is just an introduction. Over the course of the next few weeks we will be expanding on some of the themes we'll introduce today, things like automatic reclassification of point cloud data and extraction. Things like that we'll deal with in more detail again in the next few weeks. Today, just an introduction, and as part of the introduction we will also talk about how you can activate the module, how you can enable that tool within your version of Global Mapper. So a very quick look at what we're going to be discussing in today's presentation. Well, first of all, we'll answer the question, what exactly is the LiDAR module? We will activate the module. We'll show how within the context of Global Mapper you can enable that function. Now you can do that obviously as a customer if you have purchased a module. If you have not yet decided to purchase, you can activate a trial as well, and I'll show you how that procedure works. The most visible representation of the module after it has been activated is a new toolbar. Actually, it's two new toolbars along the top of your screen in Global Mapper, and we will formally introduce those components and quickly go through each of the buttons that are now available, describing what they do as an introduction to what will follow on in later sessions. What we will focus on a little bit more today is some of the point cloud visualization options that are enabled with the module. The ability to render a point cloud based on some of the inherent characteristics of that point cloud. What we describe essentially as thematic display. So we can look at the point cloud based on, for instance, the inherent classifications, or based on elevation, or based on any of the other variables that are available within the attributes of your LiDAR data. We will also, while we're talking about visualization, introduce the cross-sectional viewing capability that the module enables. Now again, just as an introduction, we will be applying this cross-sectional viewing capability in a more practical context later in our sessions when we do things like custom feature extraction or even cross-sectional editing of our LiDAR data. But for today, we'll introduce the visibility or the visualization of that LiDAR data using our profiling tool. And finally today, and this is not specific to the LiDAR module, but while we're talking about visualization, we will render our point cloud using our standard 3D viewer. So in last week's session, or the last recording, we introduced the idea of importing LiDAR into Global Mapper. It was a very basic introduction. Some of the options, the filtering options that are available. We're bypassing that today. If you need more detail on that procedure, then by all means you can view the first in the series. A little bit like a cooking show, we now have one preloaded. We've got some point cloud data preloaded, and in fact in this case, again for visual context, I have some imagery behind the point cloud. We are going to be introducing the key components of the LiDAR module today, but before we do, it's worthwhile putting the development of the module into a little bit of a context. Global Mapper as a product has supported the standard LiDAR file formats for many years, both the LAS and the compressed version, the LAZ formats. The development of the module was inspired by the requirements and the needs for more advanced functionality, and we realized that not everyone using Global Mapper would have a need for these tools, so we decided to build essentially an add-on component allowing us to develop functionality specific for point cloud processing, but again not burdening everyone that uses Global Mapper with the costs involved in that development process. So we split the two development processes out. It is worth noting that if your intention is simply to load point cloud data, to do maybe some very basic filtering and maybe generate a very simple terrain surface, you do not need the module for that purpose. The module provides more advanced functionality, as we will see in today's introduction and as we will see going forward when we actually put those tools into practice. So before we start with the module, it is worth noting that, as you can see on my screen, I can load a point cloud, I can load a LiDAR file without the need for the module. The LiDAR module was first introduced with version 15 of Global Mapper. Now, to be honest, that seems like fairly recent development for me, but I'm looking at my title bar right now and we're version 18, so that's 4 versions ago we first introduced the LiDAR module. And in the intervening 4 generations, we've really enhanced that functionality, and we continue to do that. We continue to add new tools, the most recent of which was a new LiDAR QC tool that was introduced in version 18.1. We'll introduce that one a little bit later in our series. The LiDAR module itself is actually embedded in the application that you download. From the help menu, you'll see Module License Extension Manager. Now, this function, or this tool, allows you to do a couple of things. If I enable or activate that tool, you'll see over on the right side of the screen we have access to a number of extensions. Some of them you will see in your setup. For instance, we have an overview extension, which is a standard extension we include with the application. A few that I've added myself, our friends at Aerial Filmworks have developed a custom extension for their use, and I have that one activated or available in my setup. You'll see none of these are checked on right now. Now, extensions are intended as ways in which developers can change or enhance or alter some of the structural characteristics of Global Mapper. They can build their own toolbars, essentially. The overview extension provides an example of how that works. We're not going to be using any extensions today. Rather, what we're going to do is go to the left side of the screen and we're going to take a look at a built-in module. Now, this is something that we have developed. This is something that's actually part of the application. You'll notice there's a couple in here. There's LiDAR and OTF. You will see both of these in your setup as well, and they will be unchecked unless you have activated them. What I'm going to do is activate my LiDAR module. Now, by simply checking that box, it will bring me to the standard Global Mapper registration screen. You will have seen this when you first activated the software itself. And much of the functionality is the same. We can activate the module using an order number. If we had, during the purchase of the software, also purchased the module, you can simply enter that order number and it will activate the module for you. You can connect to a network license. You can request a 2-week trial. Now, this is important. If you want to try out the LiDAR module, you're a current user of Global Mapper, you're not sure whether the module is appropriate for the work you're doing, by all means try it out. Check this final option, requesting a 2-week trial, and it will activate the module for 14 days, allowing you to put it through its paces. What we are going to do in our case is actually activate the module using a license file. This is a file that I have stored locally. I simply check that option and I'm going to hit the Register Me button, and if I can remember where I put my license, I believe it's in my webcast folder, and this is it right here. So it's just a simple ASCII file that's one of our license files. We can also activate the software itself using a similar file structure. I click Open, and you'll see immediately a little bit of a shuffle in my toolbar. I'll click OK to close the dialog box, and I now have a new series of toolbars. I'm actually going to clean them up just a little bit. I have my GPS toolbar that decided to move down a little bit here. I'm going to move it up one line and park it right up here to isolate the 2 new toolbars that have been added with the activation of the LiDAR module. Another confirmation that my LiDAR module is active is actually up here in my title bar. You'll see that I have Global Mapper 18.1. It's the 64-bit version. It is a registered version. I'm not using an evaluation. And I have the LiDAR module. This plus LiDAR is an indication that the LiDAR module is now active. So let's take a quick overview of what new functionality has been enabled with the activation of the module. Some of the benefits are not immediately visible. In fact, there are behavioral improvements, performance improvements that come with the activation of that component that we will not actually see in the interface itself. The processing of large point clouds, the generation of surface models, all of those procedures have been improved dramatically now that the module has been activated. The module toolbar itself provides me with a number of very, very efficient tools for interacting with my point cloud data. Starting with the toolbar collection over here on the right side, these buttons essentially allow me with one click to apply an updated classification to selected points on my screen. So if I have manually selected some LiDAR points, either individually or collectively, I can with one click make them ground, low, medium, or high vegetation. I can make them building points. I can make them wire conductors, power lines is what we've often used these for. I can turn them to water points, or there are a couple of additional flags I can apply. I can apply the noise flag manually, or I can apply this model key point flag as well. These are standard classifications that are available within the LAS and LAS specification. And again, these are simply manual tools. Once some points have been selected, just grab a selection of my points. They're hard to see that they're selected. I can simply click on any of these buttons to reconfigure those classifications. The other toolbar provides a lot more advanced functionality for interacting with our point cloud. First thing is a drop-down list. Now this drop-down list allows me to change the visual characteristics of the point cloud simply by choosing an alternative visualization or display option. Now the default will be RGB elevation. In other words, the display of every point in my point cloud is going to reflect either an embedded color value if one is present, which in my case it isn't, or it defaults back to the elevation. And the elevation obviously reflects the height above sea level, and you can see that reflected in my legend. Within the area I'm looking at right now, my elevation range is from 36 meters to 110, maybe 112 meters, and that's the colors that have been applied. Now the colors that are represented here also reflect the currently active shader from my standard shader dropdown. Now, this is not specific to LiDAR. This is more typically used when we work with standard elevation models. But if I change any of the settings here, for instance, if I choose my global shader, you will see that will also have an immediate effect on the display of my point cloud. Because I'm using the elevation value here, it's also applying the shader from that dropdown. Now, a global shader, as I've mentioned in previous presentations, is a shader pattern that's intended to be applied globally. So within a local context, there's not much color range to display, but I use this one just for visualization. Back to our Atlas shader again, those are the colors that are being displayed. We'll come back and look at some of the other visualization options in just a few minutes, but we're at the stage where we're introducing the buttons. Let's move along with this advanced LiDAR toolbar. The first button in the list here allows us to identify noise points, those points which are beyond the expected threshold within our point cloud. I'm not going to do any of these processes today. We will perform these procedures a little bit later, but that button activates that function. We have a button for automatically identifying within a point cloud those points that are likely to be ground. Now that can be based on a point cloud that has some ground points already, maybe some unclassified, or it can be based on points that are entirely unclassified. If you're using point cloud data that is not traditional LiDAR, that has no inherent classification, you can apply this level of intelligence simply by going through the procedure. We will do that definitely in one of our future sessions. We have tools for identifying points that are considered non-ground. Now, specifically what we've included in here are vegetation points, high vegetation specifically, which would be trees. We've also a tool for identifying buildings and identifying power lines or utility cables, basically. That procedure would typically require a higher resolution point cloud to identify those linear patterns, but those options again allow you to change the classification to reflect some of those different surface characteristics. We'll go through those procedures in a later session as well. Based on this workflow, we're kind of chronologically working along the toolbar, we have extraction tools. We can extract linear features that represent power lines, or three-dimensional polygons that represent buildings, or individual points that represent trees that are determined by the patterns of points recognized in the vegetation section. So these two tools work in tandem, reclassifying the points and extracting the points. 2 steps in that procedure. We will conduct that workflow in a later session. As I mentioned during my introduction, one of the more recent additions to the LiDAR module is a new QC tool. The QC tool allows us to compare the elevations within a point cloud to surveyed ground control. So if you want to improve the vertical accuracy of the Z values in a point cloud and you have some survey points, you can essentially offset the elevations in an interpolated fashion so that they match what you know are actual elevations that have been surveyed. We'll do that one a little bit later as well, or later in our session. We have a quick link to filtering the data. We'll go ahead and activate this one because this will look familiar. We've actually seen this option before. When we went through the process of importing data in our last session, we were given the option to remove different classifications that were unnecessary or not required. We've got the same option here. Just checkboxes allowing you to remove either based on classification or based on return type. If there are multiple returns per pulse, we can decide which of those that we want to retain for whatever procedure we're following. So just a quick link to the filtering tool. And the final button in my toolbar allows me to apply colors from an underlying raster image to the point cloud. Now you'll notice that my visualization option, as I mentioned a few minutes ago, is reflecting the RGB. Well, as I said, there are no RGB values in this point cloud. If I use my info tool and I select one point, you'll see that I have the standard LiDAR attributes, but there are no RGB values associated with this point. So what I'm going to do next is simply enable that function or apply that process. I'm going to apply colors based on the image that I quickly previewed previously, which is a standard aerial image. And when this completes, the point cloud will seemingly disappear because, again, because the default visualization is RGB, the points themselves now have inherited the colors from that underlying layer. And if I turn off the imagery itself, it should become a little more apparent that we're actually still now looking at the point cloud, but the point cloud has inherited those colors. The colors are applied based on the pixel upon which each point in my point cloud is sitting. Now, probably easier to see if I go in a little closer here. Let me use my zoom tool. And we'll go in just a little closer. And you can see now individual points with the colors that have been applied. If I turn the imagery on, you'll see that those colors reflect the individual pixels. Now this gives you obviously a photorealistic view of your point cloud. And as we'll see in the final visualization option we'll look at today, we'll bring up our 3D view. It's very cool to be able to look at that point cloud with those colors realistically portraying what's there, but in a 3D context. From the drop-down list, there are a number of other options that we can use to differentiate our points. Elevation is a standard one. Again, there's a little bit of an overlap here. Previously, we had selected elevation only as a default because there were no RGB values, but we can still override that and still display. Okay, I've just realized that I had applied for my specific layer a particular draw mode. Now, this gives me an opportunity to show another option for visualization. I'm going to double click on this layer to bring up the options. And you'll see under draw mode that I can choose basically from the same list that I quickly previewed a few minutes ago, I can decide for an individual layer how to visualize that particular point cloud. The benefit of this is that if you have multiple point clouds, you can apply different visualization options for each layer. So if you wanted to distinguish between maybe a subsurface layer and a canopy layer, you can apply a different visualization scheme. So what I'm doing here is basically deciding for this layer which visualization option to use. Now, this will override what I would normally display from this drop-down. So what I'm going to do is default back to that global setting again. So it will allow me to look through the options in this drop-down. But this is, again, just an indication that the visual characteristics of your point cloud can be altered at the layer level. We'll click OK. And let's try to do what I was trying to change as I was doing before. Viewing by elevation. As we see, this is again what we started with. We have overridden the colors. Now we are specifying elevation. A couple of alternatives here. Intensity. I can view the intensity of each return visually. Now, a lot of people, when they look at this, think it looks like a black and white photograph, and it actually does look like almost like a grayscale image here, because each point now is reflecting the nature of the surface that that particular point came into contact with or was reflected from. So you can see quite clearly there's a road going along here. You can see some open areas. You can see in this case there are some forested areas. So this intensity gives you that indication, again, a way of differentiating the intensity of the return for each pulse. And in certain situations, differentiating intensity allows you to quickly see different patterns in the surface that over which the collection process was performed. Some of the other options here, we can view by classification. Now, in this example, I've actually done some cleanup, and there are only two classes present, two colors represented. The grays I know are unclassified, and those brown points are my ground points. You can display a legend. Obviously, if you've got many more classifications than I have displayed, you can show a legend. That's something you can enable under the configuration and display option, and you'll see map legend. No map legend is going to be the default, but we want to enable our legend based on our loaded vector types, and we can give it a heading if we want. I'll just call it LiDAR. You can determine various other characteristics, including where on my screen it will appear. In my case, it's going to be at the bottom right corner here. We'll click OK, and now we can see my legend indicating, as I mentioned, ground and unclassified points. Return number. This allows me to visualize the point cloud based on the specific return per pulse. And again, it is reflected in the legend. The blue points are the first return. Now, they may also be the last return. If I select one of my points in this area that's predominantly blue, this is the first of one return. If I choose a point that's typically in a forested area, this is actually the first of three. So you can see this visualization option is a good indication where there are multiple returns per pulse, which those of you who know LiDAR is an indication where typically there's vegetation, because you tend to find with the structural characteristics of vegetation that there are multiple returns per individual laser pulse during the collection process. A couple of other options here. We're not going to go through each one. This is a personal favorite of mine, the idea of visualizing by height above ground. Now, if I choose that, it takes just a second to display, and the simple reason for that is for every point a calculation is being performed. Initially, Global Mapper determined a base level, a ground level, and from that ground level it subtracted the actual z value to come up with a height above ground. And if I click on one of these light color points, you'll see my new height above ground value. In this case, it's just about 18 centimeters above what it sees as being the surrounding ground height. One of the darker colors, one of the redder colors, this is about a 13 meter above ground point. The display is the same as previously in terms of the legend, but now these values start at a base level of 0 rather than starting at sea level. So this, again, gives me an indication of features, or in this case it's trees, and their height based on this legend. We can look at things like point index, point source ID, return height delta, which would be the difference between my first and last return. We can look at things like color infrared. If that data was present, if we were dealing with point cloud data that had a CIR value, we could visualize the CIR, and derived from that we can visualize based on NDVI and NDWI, which are calculated values, index values, indicating vegetation and water. These are typically processes that are used with raster data, but if your point cloud has a CAR as well as a red channel, we can visualize based on those values as well. One of the more recent additions to this visualization selection is point density. Now in this case it's a little unusual because if I zoom out a little, it'll probably be easier to see, but what you're seeing here is let me just remove my selected point, there we go, is the overlap paths. So we're not actually getting an accurate representation of density in, for instance, vegetation areas, but we're seeing the overlap as being reflected in the higher density. In other words, we've got two flight paths. Obviously, there's more points in that case. But if you want a quick visualization of relative concentration of points, that's what we're seeing here. Now, you will have noticed as we've gone through each of these options that additional attributes have been added to the points. For instance, our height above ground has been added. Our color values are now added. Now we also have a density value, and it's an approximate density based on the selected point. In this case, it's a fairly rounded value, 1 point per square meter. So each additional visualization option that we've added, each of these custom options, will add additional attributes to our point cloud. So there are a couple of other visualization options that we're going to show. Let's go back to looking at our point cloud based on the RGB values. The path profile tool in Global Mapper, it's not specific to LiDAR data, typically used with a terrain model to create a cross-sectional or cutaway view of the terrain. We've introduced this in some of our terrain analysis presentations. With the activation of the LiDAR module, we can now use this with a point cloud. Now, the process of visualizing a cross-section of a point cloud is a little bit different than a solid surface model, simply because we're dealing with individual points. So while we define the cross-sectional view based on a path or a line, you'll see as I get in close, a line will typically not intersect a point. In fact, geometrically speaking, it will not intersect any points given the dimension of a point being virtually 0. So what we have to do when we're creating a cross-section of a point cloud is actually expand the swath that's visible. So before you actually try this for yourself, it's a good idea, after you select the 3D path tool, as I've done on my toolbar, to right-click on the map and go to the settings. Now, we're going to be introducing some of these additional settings in some of our future presentations. For today, all we're interested in is this setting, distance from path to show, for our LiDAR profiling. Right now, in my case, it's set to 45 meters. I'm going to bring that down just a little bit. I'm going to bring it down to 20 meters. What that means is, rather than looking at the points that intersect a specific path, we're going to be looking at those points that are actually 20 meters from that path. In other words, it's almost like a buffer. We'll click OK and back up just a little bit. with my profile tool still activated, I'm just simply going to click once with my left mouse button, and you will notice as I move my cursor, as well as the yellow line indicating the original path, I have a pink semi-transparent area, which is actually that 20-meter wide swath. And I'm just going to click very quickly, left click, right click, and from off screen I will drag my profile view into the display. And you'll see here I'm looking now at a cutaway or cross-sectional view of the point cloud, not again based on a single path, but based on a buffer. I'm essentially looking through 20 meters of points to get the pattern you're seeing here. And that's why when you look at the ground points, for instance, they're not a solid ground surface, but you're looking at changes in this ground surface through that 20-meter swath. So visualization of your point cloud from a cross-sectional perspective gives you another way of interacting with your data. This will be a feature we will use a few times over the course of the next few presentations, where we talk about editing and we talk about extracting. We're going to use this tool and various adaptations of this tool for that purpose. Cross-sectional viewing gives you a very, very interesting perspective of your point cloud. Let me just try another profile here across a more open area. Again, you can see where the trees are located. You can see the fields here as well. Now, to wrap up today, under the theme of visualization, we should probably also introduce the 3D viewer in the context of LiDAR data. Our 3D view, as I mentioned earlier, with my RGB values applied to my point cloud, gives me a very realistic representation of the features that are being displayed in my point cloud. This, again, has many uses for different applications. You will see after we perform extraction from our point cloud in a later session, we'll be able to use this view to see the three-dimensional features that we've created. But for simply looking at the terrain or looking at the three-dimensional context of your points, there's no better way of doing that than using this 3D view. And certainly with that RGB values applied to our point cloud gives it a very, very realistic perspective. So today's the intention of today's presentation was a brief introduction to the module. Obviously, some of the functions that are enabled by the module include some of those visualization tools. So we kind of rounded it up by looking at some of the other visualization options. Let's quickly go back to our agenda and kind of wrap up for the day. So we introduced what the LiDAR module was. Why did we introduce the module? Why did we develop the module for Global Mapper? The process of activating, I do encourage you, if you're not currently using the LiDAR module and you're using LiDAR data, take a look at it. It's a very, very powerful tool, as we will see over the course of the next few weeks. The most apparent visible representation of the module is the toolbar. There's actually a couple of toolbars that were activated, and one of those toolbars includes that drop down. So we spent some time today just going through some of those visualization options. If you have any questions about what we covered today, best option is to go to GeoHelp at bluemarblegeo.com. Folks in our tech support team are ready to answer any questions you may have, either about the topic in today's session or indeed about any other issue you have with the application. If you're interested in ordering Global Mapper, if you're interested in a quote for either the application or for the module itself, the folks in our sales department can be reached at orders@bluemarblegeo.com. And if you're not currently using Global Mapper at all, you can download your own trial. You can activate your trial for a couple of weeks and certainly activate the module for a couple of weeks as well. So that is, again, very brief introduction to the LiDAR module. Join us next time as we expand on the LiDAR processing theme in Global Mapper.